Hello, and welcome to this video on groove weld symbols. To begin with, let me start by sharing the screen so you can follow along with the PowerPoint that I'm going to use. My name is Girish Kelkar, and I am a welding consultant operating as WJM Technologies. Additional information about my consulting business is on the web at welding-consultant.com. You're going to find this video and many others on my YouTube channel at Weld Nugget. This particular video is on groove weld symbols. This is the part 2 of this discussion. Earlier videos which are relevant to this topic are first is Introduction to Welding Symbols. This is a great video to watch if you are new to welding. In the groove welding symbols part 1, we have reviewed the reasoning why we would choose certain designs over the others, and also information about back weld and backing welds. The third video would be types of joints and welds, which also provides useful information. And of course, there are 43 other videos on many relevant topics related to welding. So let's start by looking at the most basic information out there in terms of groove welding is the gap or the root opening. So when two parts are welded together, they don't have to be butted against each other with a zero gap. So they can have a finite amount of gap, and that actually helps with the process so that the fusion goes down and can able to fuse all the way down to the root. So the gap can be specified by the design engineer. In this case, it's 1/16 of an inch or 1.6 millimeters. And that is shown in the welding symbol between the symbol itself, within the symbol itself. So in this case, it's a square groove weld. So these are two vertical lines which indicate a square groove weld. And the gap of 1/16 is written right in between them. So gap between parts is always mentioned within the groove symbol, whether it's a square groove or a U groove or V or flare, the gap information is always there. Keep in mind that in the symbol itself, you will not see the units. So it won't say 1/16 of an inch, it will just say 1/16. You have to look at the whole drawing to make sure which units it is written in. There can be a lot of additional information which can be specified in somewhere else on the drawing, but might be very relevant. So in this case, let's say there's more information in note 1. So on the part drawing, you look for note 1, and that can specify many other details which are maybe required by the design engineer, and that can include how to make that cut. How do you make that square groove cut? It can be an option whether water jet, bandsaw, plasma, laser, machined, or EDM, or maybe a few other techniques. So in case it is not mentioned, the manufacturing personnel are free to use what they prefer. But if it is mentioned, they have to use that particular technique. Additionally, there can be requirements for edge break, chamfer, and deburr. And I have found them to be quite useful in avoiding defects such as fine porosity. So these are edge preparation techniques are also very important. There can be requirements for wash, clean, and dry, and etch and storage. Now, these are very important for all welding, and etch and storage is particularly important in when it comes to welding aluminum, and especially for aerospace applications, where the parts have to be etched and stored and have to be welded in a very short amount of time thereafter. These details might be in note 1, or they could also be in the weld specification. So you may have to read that one very carefully as well. So in this case, we have looked at the root opening, and gap was the older name for root opening, but now the technical name AWS, American Welding Society, is preferring is root opening. In addition to that, there can be other numbers in the weld symbol which are relevant, and I'm going to show you in a schematic form on the left. Here we are seeing a square groove weld which has been welded. I'm showing you the fused zone with a darker contrast. And we can see that the fusion zone has gone down into the square groove down to about 1/4 of an inch. And the length of the weld along the length of that component is about 1 inch. So how do we show that on the welding symbol? Of course, the gap still remains to be 1/16 of an inch. Now again, keep in mind this gap is before welding, and sometimes there can be closure of the gap because of the welding process itself. So here we see the welding symbol. Now this welding symbol is not actually attached to a drawing. So the arrow is not touching the weld itself. If this was actually on the drawing, then that arrow, the point of the arrow has to be in contact with the weld interface as shown on this on the right over here. So in this case, this is just the welding symbol just for your information. So here we have the weld symbol that is for the square groove weld. These are two vertical lines. The gap is 1/16 in between, as we have discussed before. Now the weld size is how deep the weld is going into the groove is shown to the left of the welding symbol in round brackets. In this case, it is 1/4, and that is 1/4 of an inch. And the length of the weld is to the right of the symbol is 1, that is 1 inch. In the tail of the weld, you will see PJP, that is partial joint penetration. That indicates that the weld is not going to go through the thickness of the two components. In this case, it is obvious from the schematic, but it is also obvious mentioned over here. And it is also obvious because we have mentioned the weld size. If the weld size was not mentioned, then we would default assume that this is a CJP weld. That means the weld will go full penetration into the square groove. If the gap was not mentioned, then we have to assume the gap is 0. So if the gap is not mentioned, you assume it is 0. And if the length is not mentioned, then we have to assume that the entire length of the component is welded. So if the length was not mentioned, the weld will go all the way the length of the component. So we could have a situation where none of these are mentioned and still would provide relevant information. In situations where you want the weld to drop and have a positive root drop on the other side, so that is referred to as melt through. So there are situations where we want to make sure that the weld not only goes through the thickness of the weld, but also protrudes a little bit on the other side. And that is shown by the melt through symbol. Now, melt through symbol is on the other side, and that's why it is shown above the horizontal line. The square groove symbol is below the horizontal line, indicating that the energy is going to come from the top. And as I've shown in the schematic over here, usually when the energy comes from the top, the weld is wider over there and narrower towards the bottom. Now, this is just a schematic cross section, and this is not going to be on the drawing. On the drawing, it's just going to be a square groove weld. So here we are seeing, we are not mentioning the gap. So the gap is 0 in this case before welding. We are showing a melt through symbol, and there's a number 1/16 to the left of that symbol, and that is the root drop or melt through. The melt through, the dimension can have its own tolerance. So you can have, say, +0, -1/32. So if you want a specific tolerance on the melt through, you have to specify that in the tail of the weld or in a note somewhere. If it is not mentioned, then the default tolerance will be assumed. The fact that we have melt through implies that this is a CJP weld. That means a complete joint penetration. Without melt through, you would not have a CJP. So the fact that we have melt through, then it is obvious that it has to be CJP. So that's why you're not going to mention that in the tail. And the melt through symbol typically works only when the entire weld is made from one side. So this is not going to be welded from the other side. Once we go beyond square groove and we go into the complications related to V groove, we have to add a few more pieces of information to the welding symbol. Here on the left, we are seeing the schematic of a V groove weld before welding. We are seeing there is a V. The edge is, of course, not a square anymore. It has a V, so there is an angle on either side of the two components. The gap is 1/16 over here. The angle is 60 degrees. And when there is no specific mention about the angle, then we assume that both sides are machined 30 degrees. So we assume that the angle is symmetrical. The thickness of the component is 1 inch. And over here, we can see the groove depth is expected to be 7/8 of an inch. So the groove depth is the depth from the top surface to the bottom of the groove. And with all of that, you end up with a small portion which is still considered square groove or effectively square groove, and that is called the root face. So now we have new terms because of the V groove. We have the groove angle, we have the root face, and we have the groove depth. So these are three new numbers that we are dealing with. So how do we show that in the symbol? So as I mentioned before, root opening is a preferred name for gap. And in the past, a lot of people used to refer to the root face as land. So you might see on some old documents the gap and land, but now they are referred to as root opening and root face. So these are the preferred AWS terms. The groove angle is shown over here, and the groove angle is also shown in the weld symbol. So the weld symbol for V groove is are two lines which are 90 degrees to each other and 45 degrees to the vertical. The first number in there is still the gap. So we are still going to show the gap over here, 1/16th. And just below the gap, that number, we're going to show 60 degrees. 60 degrees is the only number, the degree angle is the only number we actually show units. So it's not radians, it is 60 degrees. And since there is no specific mention, then we assume that the 60-degree is split evenly on both sides. So each side has a 30-degree machined surface or formed surface in some way. To the left of the symbol is a number 7/8, and which is not in the bracket. In the previous symbol, we had shown a number in the brackets over here. That is how deep the actual weld is. In this case, we are just showing 7/8. That is the actual groove depth. So what is not shown over here is the actual root face number. So the root face is a calculated number. So now we know that the component is 1 inch, and we know the groove depth is 7/8, and we minus 7/8 from 1, and we get a 1/8 root face. Again, keep in mind that the root opening is not necessary, it can be 0. The root face also is not necessary, it can be 0, although in practical terms, it is better to have a little bit of root face, otherwise you have a very sharp edge at the bottom of the V groove. So this is the information, critical information in a V groove. The V groove depth, the gap if present, and the angle, and the root face. The information is not here, but it is back calculated based on the thickness of the component. Now we add additional wrinkle of how deep the weld is. So in this case, I'm showing you two schematics. One, and both are similar in the sense that both have a groove depth of 1/2 inch. So we have two pairs of welds. Both have V groove depth of 1/2 inch. But in one case, the weld has gone down only 3/8 of an inch, which is less than half. And in the other case, the weld has gone down 5/8 of an inch, is more than the groove depth. So that is a choice. That is a choice for the design engineer. You don't have to go through the entire depth of the V groove. So that is shown by a bracket, closed curved brackets to the right of the V groove depth. So in this welding symbol, we're going to see number 1/2. 1/2 is the groove depth, and 3/8 is actually the weld size, is how deep the weld is going to be. 60 degrees is the included angle, and the gap is 0, and the same on the other side, 1/2 inch groove depth and 5/8 inch weld size. So the weld is deeper than the depth of the groove. The fact that we are showing a weld size, that implies that this is a PJP weld. So you don't have to say it's a PJP weld, because you know we have specified the weld size. That is typically implies it's a partial joint penetration. If the size is not mentioned, then we would assume it's a CJP. So let's say you have a V groove with a 1/2 inch V groove depth, and there is no mention of how deep the weld is going to be, then you pretty much have to make the weld full penetration. If the weld size needs any tolerance, special tolerance, then that has to be specified in the tail of the weld, which is not shown over here. Now we add to the complication of a V groove design to go with a double V groove design. That means we have two V's, one from either side. Again, the symbol gets a little bit complicated. Essentially, it's a duplication on the arrow side and the opposite side. But they can be different. So here I'm showing you a schematic of a V groove from the top, V groove from the bottom. The angle is different. It's 90 over here and 60 over here. The gap I'm showing you as 0. In both cases, the groove depth is 1/2 inch and the weld size is different. So let's look at the arrow side. Let's say we are going to come from the top over here, and The symbol is going to be pointing to the weld from the top. So this weld would be the arrow side weld. So that information will be below the horizontal line. So let's see what information is there. We see a gap of 0 between the two parts, the angle of 90 degrees over here, the weld size is half, and sorry, the V groove depth is ½ inch, and the size is 5/8 of an inch. On the other side, the weld on the bottom side will show up above the horizontal line. And over here, we do not show the gap because the gap in this case is only shown on one side. So once you show it on one side, you don't have to show it on the other side. You can show either side, but not both. So the gap is already mentioned 0, so we don't mention the gap on the other side weld. We mention the angle, mention the groove depth, and the weld size. So all of that information is included over here. So this is something important to keep in mind. The size, groove size, angle, and V-groove depth can be different on both sides. Over here, I'm showing you these welds are made and they are not joining in the middle. So it's not considered a full joint penetration. However, you can specify that these welds will ultimately overlap and then it could become a complete joint penetration. Another important information, especially as the V grooves become larger, is it requires number of passes to fill up that V groove. So if the V groove is deep enough, you may require 10, 15, 20 passes. But that information, again, is not in the groove symbol. Usually that information is not provided. It is up to the manufacturing team to figure that out, is how many passes do we need to make sure we meet the specification. If there is a need to specify that, then that can be provided in the note or in the welding specification or a shop traveler or any other related document. But that is typically not in the welding symbol. Let's look at a variant of these shapes, what is called the bevel groove. So bevel groove essentially is a weld where the V groove or a V portion or the slant is only on one of the components. The other component is straight. So on the left, I'm showing you a schematic of two parts, one with a straight edge or square and one with a bevel. And the weld has been filled up over here. That will show up on the part drawing. Again, this will, in the part drawing, it is still going to show as a square groove weld. The only thing we are going to show differently is on which component we are going to make that bevel. Excuse me. If it is not important which component, then you can just have a straight arrow. But if it is important, then you have to have a broken arrow with the broken arrow, the last bit pointing to the part on which that V or bevel has to be made. And the bevel groove symbol, as mentioned in the previous video, is a vertical line with a angle line at 45 degrees. Again, over here, I'm not showing all the other details which can be filled in, such as size, shape, depth, gap, and so on, and angle. But I just wanted to emphasize that the location where the V groove, the bevel has to be made, can be indicated in the welding symbol. In some situations, it is not important to indicate that because it is quite obvious from the geometry itself where the bevel is going to be. Over here in the schematic, I'm showing you two parts, part A and part B, and they are connecting as a T-joint. Now, in this particular case, you have to make the bevel on part B. You cannot make that on part A. So it is quite obvious that if there is a bevel groove symbol, so in this symbol, you can see it's a bevel groove. And we know based on the part design that the bevel has to be on part B. So it is not shown with a broken arrow. Here the bevel angle is 45 degrees, the gap is 0. Again, we can see the 0 number over here, 45 degree number below that. And the depth of the bevel is 1/4 inch and the weld size is also 1/4 inch. So the design engineer is expecting you to make a weld which is just about as deep as the bevel itself. Obviously, it's going to be slightly more deep to make sure that the root of the weld, which is the point where the bevel and the vertical face come together, that point is called the root, and that is going to be fused. So this is the interesting variation in bevel groove that you have the choice sometimes. Sometimes it is obvious. Sometimes it is defined by the part as part of the drawing itself. Similar to V groove, there can be a double bevel groove. Instead of double V, there's a double bevel. Now, double bevel means there is a bevel and you're going to weld from the arrow side and then from the other side. So on the part drawing, the double bevel is going to look like this. Again, excluding all the other details, we are going to see a bevel below the horizontal line showing the arrow side and bevel above the other side. But now that begs the question is where exactly is the bevel going to be made? But according to AWS, if you see a symbol like this and there is no specification or nothing on the part drawing or in the note or where that bevel is going to be made, then the manufacturing team can go ahead and make the bevel on either or both sides in any configuration. So we have four different options. So both bevels on one part, both bevels on the other part, the top bevel on one, bottom on the other, and top on the other side and bottom on the other side. So all of these combinations are permitted by this welding symbol, unless specified in the part drawing or in a note or in a schematic by the design engineer. And the same holds true for double J, which is similar to double bevel. As we have seen in the previous video, as the welds get deeper and the parts get thicker, you end up moving typically to a U groove for various reasons discussed earlier. And the symbol gets a little bit more complicated. So here I'm showing you a schematic of a U groove. U groove essentially is two J's put together to call it U. So if you just look at one, it looks like a J. When you put all of them together, it looks like a U. So again, the component is 1 inch thick. The groove depth is 7/8, and the groove angle is 30 degrees. And if nothing else is mentioned, you assume it is symmetrical, 15 degrees on both sides. Now, and the gap is there. And now we have some additional information, which is the radius. There's a small radius at the bottom of the U, which essentially makes it a V. Otherwise, it would have been a straight line, would have been a V. But now we are coming down and we are making a small radius over here, which is say 1/8 of an inch. Let's look at the symbol. The U groove symbol is, in this case, the arrow is coming from the top. So that would be the arrow side, and it's like an upside down wine glass over here. The gap is 1/16 is shown over here. The angle is shown 30 degrees. And the depth of the U groove is shown as 7/8. What is not shown over here is this radius 1/8 of an inch. Now that radius will not be shown on the symbol. It will actually be in a small detail drawing on the main drawing. It's on the main assembly drawing itself. So that radius information is not in the symbol itself. That has to be shown separately. Or any other features of the shape. The shape doesn't have to be a perfectly U. As you can see, it's not like a perfect symmetrical vertical wall U. It actually has a inclined U surface. So any other piece of information regarding that profile, all of that information has to be in the detailed drawing separately. It is not included in the U groove symbol. Similar to U groove, J groove essentially is half the U groove. So essentially the U profile, half that profile is on one component, the other component is straight, and that makes a J groove. In this case, again, I'm showing you a J groove made in a T junction. So the two parts are coming as a T, part A and B. Again, here it is obvious that you can only make the J, practically speaking, on part B. So there is no mention or reference to that in the welding symbol. Again, we have the gap. Gap in this case is 0. The angle of the J is 15 degrees as shown over here. And again, we have a 1/4 inch depth of the J groove, and the size is also 1/4 inch. So you're just wanting the manufacturing engineer to make a weld just about equal to the depth, maybe a little bit more, just to make sure the root is fused. And now you have an additional wrinkle on that, is that on top of the weld, we are now asking the manufacturing engineer to also make a fillet weld. So we have a J groove symbol, which is half the U groove symbol. And then you extend that vertical line and you add a fillet weld symbol over here. The fillet weld leg size is 3/16. Now these details are in the first video that I've shared, Introduction to Welding Symbols, and you can look at that over there. So here, essentially, we are making two welds. You're first making a J groove weld, and then on top of that, we are adding a fillet weld. So it is quite common for single bevel designs, in this case, I didn't show that, but it would be quite common to have a additional fillet weld over here and the additional fillet weld on the J groove design. So it's an overlaid weld. Now, the manufacturing engineer has the option of making these two separately or making both in one pass. And that's also possible. I've seen that where the depth is small enough, or the bevel in the sometimes is small enough that you can make the bevel groove weld and overlay that with a fillet weld in one pass. So that is also possible. Again, that is not specified on the drawing, whether you have to do it in two passes or one pass. All the symbol is saying is you have to meet these specifications outlined in the welding symbol. Similar to a double V groove or double U groove, there's a flare V groove. So, and that happens naturally when you have two components which have a curved surface. In this case, I'm showing you two pipes which are being welded together. So it automatically naturally forms a flare V groove. So instead of single, like a vertical wall, straight wall V, it's a flare V. The symbol of the flare V groove is shown. Again, the gap is shown over 0 over here. So the pipes are touching before the weld. And that is the root of that weld. Right where the two pipes, assuming they are equal dimension, touch, that's the root. And the depth of that groove, you don't have to make the V groove or flare groove. It naturally forms because of the shape of that object often. And that is 7/8 of an inch. So in this case, that would be the outer radius of that pipe or tube would be the depth of that flare V groove. And the size of the groove, so this is actual weld, which I've shown with a slightly darker contrast, is 1/2 inch. And that is shown in the curved bracket to the right. So the full depth is 7/8. The weld itself is only 1/2 inch. So it is quite common that for arc welding processes, root fusion is not expected. So flare groove and flare bevel are quite common in arc welding processes, but the arc energy often is not able to penetrate down so deep to actually fuse this without actually affecting the ID of that pipe itself. So root fusion is not expected in flare V groove, as opposed to say other weld designs such as V or U or others where it is specified and it is expected to have that root fusion if specified, of course. But here it is not practical, so it's not never specified. The weld size is always going to be less than the groove depth because we don't have root fusion. So the weld size is going to be less. In this case, I'm showing you that the weld is not going all the way to the surface and it is also not root fusion. So it is smaller, has gaps on both sides. In some applications, the design engineer may require the root face to be flush. So this front edge, the top surface of the weld, the face of the weld, may be required to be flush or even slightly proud of the weld, but that has to be specified. The way the schematic is shown over here, you are seeing a slight underfill in the weld. So there's a gap over here, which it's not a physical gap, it's below that tangent you would have drawn. It's below that surface over here. Similar to similar to J groove or a bevel groove, there's a flare bevel groove, and the story is the same. The V groove depth, in this particular case, the groove depth is the radius of the outer surface of that component which has a curved surface. In this case, that is 7/8 of an inch. The depth of the flare bevel groove, the size itself is 1/2 inch, I've shown over here. And here again, I'm showing you a bevel, a fillet weld on top of the flare bevel groove. So we are going to make a weld which covers this portion and then make additional weld on top, which is a fillet weld. And this is again quite common. It's quite common to have the flare bevel groove paired with an overlaid fillet weld. So this combination is quite common. Okay. A variant of all of these is welds with a spacer. So sometimes, because of the convenience for the design and manufacturing, it is easier to separate the two components to a fixed distance by actually placing a spacer. Now, in this case, I'm showing you what appears to be a double V groove. So there's a V on both sides, and the spacer is shown as a rectangle and empty, not a filled rectangle, an empty rectangle right on the line. And you can see the vertical lines of the V going on either side. In this case, the gap is the width of the spacer. So the gap is actually controlled by the spacer width. In this case, it is ½ inch, which is shown on one side of the symbol. It doesn't have to be shown on both sides. And the angle is 20 degrees on both sides, which is shown over here. That angle could be different on both sides. The details of the spacer can be in the tail of the weld or some other note somewhere, but in this case, it's in the tail. It says 1/4 inch by ½ inch, and the material is 304 stainless steel. The spacer essentially acts like an internal backing plate. So when you're making a weld and you have a gap, and suppose the gap is going to be much bigger than you can control, it is better to put a spacer so that you can make the weld from the top without having the risk of the molten metal just dropping down. And then you can actually come back if required. You can actually come back from the other side. Once the arrow side welding is done, you can gouge out the spacer and then fill the back side, the other side weld. So that's an option. That's an option. Or the spacer can be consumed. If the spacer is made of a suitable alloy, then the spacer can actually be consumed into the weld and it remains there. So spacers can be in all of these double type welds. You can have double V, double U, double J, and double bevel. You can have spacers placed in them. Similar designs for single side, so V, U, and J groove welds, where we actually can place a spacer, but now it is called an insert, and that is placed in the root of the weld. So here I'm showing you a schematic on the left. We have the angle of 60 degrees. In this case, the gap is 1/8, which is actually the width of the spacer. And the spacer is 1/8 by 1/8. And obviously the spacer is going to be long as the component is there. So it could be a long square section. The consumable spacer is shown above the horizontal line. So it is obvious that it is coming from the other side. So consumable spacer is an open square symbol over here. There's a V groove symbol. 1/8 is the gap and 60 degrees is an angle. Here again, the spacer is placed from the other side, and then it can be gouged out or it can be consumed. So it's a consumable spacer, but it can also be gouged out, and then you can go from the other side and make a back weld. So again, this can be used for both all U, V, J, and bevel grooves. So the spacer can be there. So there are multiple choices of information and relevant information that needs to be included in the weld symbols for square, U, V, bevel, J, and with spacers and with inserts. Again, keep in mind that in all of these slides, I have shown most of the times specific information relevant to the discussion, but the actual welding symbol can sometimes get very complicated, especially if you have two separate designs on either side, two different, maybe even processes from either side, then includes gouging and angles, and it can get very, very complicated. So reading that weld symbol, you have to require a lot of patience to make sure you go through all of that and make sure you understand what exactly the design engineer is expecting you to do. So in summary, square groove welds are simplest for part preparation. So you just need to have a properly cut surface and with the required gap. And that is not trivial. So you still have to follow the rules and regulations to make sure you are meeting the expectations for the design engineer. Thicker parts will require a groove, and that adds to the additional complication of manufacturing that V groove and have the right angle and the root opening and the root face. So, and then comes U and J, where the profile is a bit more complicated than just having a V profile. And those details have to be included in a detailed drawing. They won't be on the symbol. All groove welds, including V, bevel, U, J, can be specified to have melt-through, back, or backing welds. So a lot of these welds can include all of these or combination of those. Flare V and flare bevel grooves are similar, but not expected to have fusion. So the main difference between the flare type designs and the bevel type designs is that you're not expected to have root fusion, especially with arc welding processes. Root fusion is potentially possible with directed energy processes such as, say, laser beam welding and electron beam welding, but fusion arc processes, it is not so practical. You can use spacers and consumable inserts. This is kind of similar to the backing plate that we talked about in the previous video, Groove Welds Part 1. And here again, that allows the manufacturing flexibility in getting the right gap without exposing the weld to the environment on the other side very easily. And here again, we can have spacers which are either consumed or left in place after the welding. Again, that is to be specified in the drawing. The reference documents that I've used are AWS A2.4, which is the standard symbols for welding, brazing, and NDE, and AWS 3.0, which is the standard welding terms and definitions. Again, AWS is American Welding Society, and the symbols mentioned over here are going to be slightly different, especially other side and arrow side, compared to the European welding symbols. I want to thank you all for your patience in watching this video. If you're interested in learning more about welding and joining, please subscribe to this YouTube channel. And there are many videos. In fact, right now there are 46 videos in different playlists on this channel. And so if you're interested in learning about welding, this is a great place to start. I want to thank you once again and wishing you the very best in learning more about welding. Take care.